Okay, welcome back, mathletes. So today we're going to be taking a look at the target round from the 2024 State Math Counts competition. This came out recently and I did a couple videos on the sprint round, so feel free to go and check those out. But today we're looking at the target round. So we have 8 problems to get through and we're allowed to use a calculator on this one. So let's jump right in. Just a reminder to try out the problem on your own before you watch the solution. It's the best way to learn. All right. This one says that you've got a glass jar holding some cotton balls, and altogether it weighs 16 ounces with the jar and the balls. So the jar plus the balls is 16 ounces. And when the number of cotton balls in the glass jar is tripled, the total weight of the glass jar is 24 ounces. Okay, so you've got jar plus 3 times the number of balls, and the balls all weigh the same, so that's just going to be 3 times the weight. That's going to be 24. And if you subtract these two, you get 2b is equal to 8, so b equals 4. And what do they want to know? They wanted to know how many ounces the jar weighs. So since b is 4, j must be 12 from this one. So j equals 12. All right, that one wasn't too bad. Let's go ahead and take a look at the next one. This one was a tricky one. This one says the figure shows the cross section when Yuri wraps a piece of wire around 2 logs, one of diameter 6 centimeters, that's the small one here, and one of diameter 18 centimeters. Okay, so let's take a look at this. So it wants to know the total length of the shortest piece of wire that can be wrapped around both logs as shown. Okay, so since it's the shortest piece of wire, we know it's nice and tight around the circumference of these two, but we have to figure out how much of the circumference is being covered by this wire on this log, and then how much of this circumference, and then also the distance of the straight line that connects here and here. So one thing that you might think about is, what if we were to extend this tangent line? There's a tangent line here we could extend, and it's tangent to both of these logs if we extend this line. And what will happen is that tangent line will intersect this other tangent line coming from this direction, and yeah, so they'll intersect here. And if we draw a straight line from that point through the center of this circle, and again through the center of this circle, it may not be the exact center, but we get the idea. You'll have a triangle here. I'm going to draw. I think this line is just a diameter. It's not necessarily the line tangent. It looks to me like the line tangent is about here. I'm going to draw that one. Since it's tangent, I have a perpendicular line here, since the radius of a circle is always tangent to, or sorry, it's always perpendicular to a tangent of the circle. And I'm going to do the same thing for the smaller circle here. And what this is going to do is going to give me some similar triangles, because these two triangles here, they share a common vertex here, and so they share an angle. So because those triangles are similar, and I know this radius is 3 and this radius is 9, I know that the ratio between this distance here and this distance here has got to be that 3-to-1 ratio. That's that's between 3 and 9. So let's do a quick little bit of math here. I guess I don't know what this distance is. I know it's got 3 here, but I don't know this little bit here, this blue bit here. So let's call that bit x, since I don't know it. So we've got x plus 3. That will take me all the way to the center of this circle. That's x plus 3. If I divide that by 3, that will give me the ratio of the hypotenuse to the shorter leg. And that should be the same as that ratio for the bigger triangle, which is x plus 3 plus another 3 plus 9. So we got 6 plus 9 is 15. That's x plus 15 divided by this shorter leg, which is 9. If I multiply both sides by 9, I have 3x plus 9 on this side is equal to x plus 15. I can subtract 2x plus, let's see, or I can subtract x plus 9. That'll give me 2x here, and it'll give me 6 here. So that means that x is just equal to 3. Now, if this is 3 and this is 3, I have a hypotenuse of the smaller one of 6. And I've got a shorter leg of 3. So this is a 30-degree angle here. And we have a 60-degree angle here. So we've got in there is 30 degrees. Here is 60 degrees. So we have a 30, 60, 90 triangle. All right, that's great because that's going to tell us how much of this circumference here is covered by wire. If we have a line going here, we have 60 degrees here. And so this 60 plus 60, this 120 here is 1/3 of the bigger circle. So that means the other 2/3 has got wire right along the edge. And then we've got this, so that's a big part of the wire, but then we've got these 2 chunks here that are straight. We've got these 2 straight bits. So we need to figure out how long those are. So let's see. Actually, that should not be too bad because we know that the total distance across here, the longer leg of the bigger triangle, should be 9√3. 9√3. That's the entire distance. And of course, this small bit here is 3√3. So this bit here is 6√3. And the same thing on the other side since it's symmetric. 6√3. Let's see, the total circumference of this circle would be, let's see, pi times 9. No, pi times 18. 18 is the diameter, 9 is the radius. So pi times 18 would be the entire circumference, but we only want 2/3 of that. So 2/3 of 18 is going to be 12. So we have 12 pi going around like that. We have 12√3 if we take these 2 straight bits. And then in here, if we were to take the entire circumference of this one, it'd be 6 pi. But since we're only taking 1/3 of it, we have 2 pi. So we just need to add those all up. Let's see if we can just write it out here real quick. So make a little room. So we're going to have 12 pi. Let's see. We have 12 pi from this bit here, plus 12√3 from the 2 straight bits here and here, and then we have 2 pi, if I did that right. So you're allowed to use a calculator since this is a target round, so I'm going to bring Python. I'm going to bring a little Python window in here, and we'll see if we can compute this here. So 12 times the square root of 3, well, yeah, 12, I should have done this in order. We had 12 pi plus 12 square root of 3, and then plus 2 pi. I guess I can just make that 14 pi, can't I? And so that gives me 64.76 centimeters. They wanted it to the nearest whole number, so we're going to call that 65. And we'll put that in for our answer right up here. 60, whoops. That's not what I wanted to do. 65. All right, great. Let's move on to the next one. This one says a group of 84 people attended the zoo field trip. 63 people rode in the bus. All right. And the remaining people were in cars with 3 people in each car. Okay, so how many is that? 84 minus 63 is 21. We had 21 people, 3 in each car. So that means we had 7 cars, right? We had 7 cars. 7 cars with times 3 in each. That'll give us our 21. And on the return trip, the same cars carried 4 people each. Okay, so that means that 7 additional people went in cars. That means those 7 people had to come out of the bus or had to not go on the bus. And the remaining people rode on the bus. How many people rode on the bus on the return trip? Okay, well, there were 63, and now we just take 7 away from that, right? So that'll give us 56 people on the bus on the way back. So that's the answer to that one. It's just 56. That one was not too bad. So a lot of times they give you one easy one and one hard one on a target. So a lot of times the odd numbered ones are easier than the even numbered ones, but not always. All right, let's take a look at this one. This one requires a lot of calculation and sort of some patience to go through this because you've got a giant histogram here. And they're saying that it shows the ages of the people who attended a book signing for a popular author. What is the absolute difference in years between the median age and the mean age of the attendees? Express your answer as a decimal to the nearest tenth. So it's testing whether you know what a median and a mean is, and also whether you can type a bunch of things into your calculator really fast in the time. But what we need to do, in order to find the median, let's count down from the top, and we'll count up from the bottom and sort of meet in the middle to find out what the median is. And we're going to need to know the total count in order to compute the mean, so let's keep track of that total count. I'm going to start here, 1, 2, 3, 4, 5, plus we got another 5 here is 10, 12, and another 7 gives me 19, another 2 is 21, another 6 is 27. So up to this point I've got 27 that are up here on this side of that line. Let's count another 27 from this side and we'll see how many more we need to do. So here we go, 1, 2, 3, plus 11 is 14, plus 13, 14 plus 13 is already 27, isn't it? So there's 27 down here. There's 27 here. So let's do a few more. Well, actually we can already see that all that's left is these two bars here. This one is taller, the one that has 20, so that's going to be our median. That's going to be our median. It's going to be 20. But we still need to know the total number, so I've got 27 down here, 27 up here, and how many are inside in between? We've got 12 plus 9, so we've got 21 in there. 21. Okay, so that'll give me 60, 74, 75 total. So there's 75 students total. And now to compute the mean, I just need to get my calculator and do a bunch of computations. So let's grab that in here. I'm going to make it a little, let's see, make it really narrow so that I can see everything. Let's see what we can do. So we have to have 16, I'm going to put this all in parentheses, and then I'm going to divide by 75. So I just need to add up all the ages, and I can multiply where there's multiples. So I've got one 16, plus I've got two 17s, plus I've got 11 18s. Hopefully I don't mess this up. Plus I've got, not 11. Yeah, 11. Okay, and then I've got 13 times 19. So I've got 13 that are 19 years old. That's the mode. That would be the one with the most. And then I've got 12 times 20. And I've got 9 times 21. And I've got 6 times 23. This is the boring part of video where you go at 2x speed. I've got 2 times 24. And I've got 7 that are 28. And I've got 2 that are 30. Then I've got the old folks, not as old as me, but old folks. We've got 5 times 35. Plus we've got one 36-year-old, and we've got two 38-year-olds. I'm running off the edge of the screen, aren't I? Let me just fix that here. Okay. I've got two 38-year-olds and I've got two 40-year-olds. Let me just check and see. I've got 16, two 17s, 11 18s, 13 19s, 12 20s, 9 21s, 6 23s, 2 24s, 7 28s, 2 30s, 5 35s, 1 36, 2 38s, and 2 40s. This should be right. So this is going to be the mean age, and that's 23.1 something, 23.107. But we are looking at an answer to the nearest tenth. So we can just take 23.1 as our mean, since our median is an integer. So our mean is 23.1. And we're going to take the difference between the median, which was 20, and the mean, which is 23, and that's going to give us 3.1 as our final answer. Okay, great. That was a lot of punching numbers into your calculator, but we got the right answer. Okay, let's go on to problem 5. So this one says, on Monday, 5 mushrooms popped up in Sean's yard. On Tuesday, 15 new mushrooms popped up. So 5, then we got 15, and that's a total of 20. And then on Wednesday, 45 new mushrooms popped up. And on Thursday, 135 new mushrooms popped up. And it says this pattern is going to continue with the number of mushrooms tripling every day. They want to know in total how many mushrooms will be in Sean's yard at the end of the day on Sunday. So these are all multiples of 5. So we could do 5 times 1 plus 3 plus 9 plus 27 plus 81 plus 243. And what day am I on? This is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. I need one more to get to Sunday. This is going to be 9 cubed, which is 729. And you can get your calculator and add that up. There's also a trick to adding up an exponential series, but in this case, I don't know. It seems like it's not too bad to just add this one up. So I'm just going to do it this way. 1 plus 3 plus 9 plus 27 plus 81 plus 243 plus 729, and the total I get is 5465. So we'll put that as our answer, 5469. That's a lot of mushrooms. Did I do that right? 546. Oh, I typed it wrong. Whoops. That was supposed to be 5465. Let me fix that. 5465. I just wrote it wrong after I got the right answer from my calculator. Don't make that mistake. Okay. All right, let's go on to number 6. We've got 3 more to do. All right, this says you have a strip of paper, and in step 1 you fold it up like that, and it says the paper is 6 centimeters in width. You fold it up, then you unfold it. Now you've got a line segment, and then you do a second fold, and when you do the second fold, the corner of the paper comes right to P, it says. So it says, and that fold is also made through point Q, and the edge coincides with that first fold. And then in step 4, it's unfolded, and the other endpoint of the second crease is labeled R. So we've got this nice triangle here from those 2 folds. And it says the area of our triangle in here is 36 centimeters squared. And it wants to know what QR is. So we're looking for this distance here, this distance of that QR, that second fold crease. And what else? Does it give us anything else? No, but it asks us to give our answer as a decimal to the nearest hundredth. So what do we know here? We know that when you're in step 3 here, that this edge of the paper from Q out to the corner exactly coincided with PQ. So that means that this length here, PQ, has got to be the same as this length from Q out to the edge point here. Those have got to be the same length. Another thing you know is that this angle in here, let me see if I can use a different color. So that angle there has got to be the same as, as this angle over here. So those 2 angles have got to be the same also, because when you folded it, they lined it right up. So you know those are the same. We don't know what those distances are or what those angles are. Are there any distances we can compute? Well, we know the height of the triangle is going to correspond to the same as the width of the paper, which is 6. So we've got this triangle. Maybe I will draw it with my line tool here. We've got this triangle here, and we know that the area is 36, right? And so we've got an area of 36 in here. And we know that the height, if we were to drop an altitude here, the height is 6. So what is the base? Well, the base times the height divided by 2 is going to give us 36, so the base has got to be 12. That's the only way we're going to get that to work out. So the base is 12, and let's see. That base is the distance from P, which is here, to R, which is here. Now, if I were to draw that line on the back of this part, I would see that that's also the same distance as from R up to this corner here. So that is 12. And this one is also 12. 12 and 12. Okay, so yeah, so let me draw that. We've got like a parallelogram now here. And this is 12. This is 6. This is our x that we're trying to find, this hypotenuse here, or this length here, I guess. And then we don't know this length, and we don't know this length. But we do know that this angle here is the same as this angle here. And we also know, I guess, that this angle here has got to be the same as this angle here. And so we have similar triangles, right? This angle, so I'm going to put a dash there, I'll put 2 dashes here, 2 dashes here, and then I could maybe put 3 here, and 3 here. These are similar triangles here. And actually, not only that, actually these 2 lines, let's see, do we know? Yeah, I guess these 2 lines are parallel and these 2 lines are also parallel. So it is a parallelogram. It's also, yeah, I guess it's actually a rhombus too, because, yeah, if I'm not mistaken. But anyway, I don't think we necessarily need to know that to solve this problem. But what we need to do is we need to look at the different ways you can solve for the area of a parallelogram. One way to solve the area of a parallelogram is to do the base times the height, right? So that'll give us 12 times 6, which is just equal to 72. That's the area of this thing, which we could have also said, because we have 36 here and this is also 36, because it's a congruent, I guess they're really congruent triangles, right? Because you've got the same length here on the shared corresponding side. So another way to compute the area of a rhombus, or a parallelogram for that matter, is to look at the diagonals. So you can get okay, sorry, I am back. I had to take a break to take a phone call. But I realized when I was pausing the recording that we do need, I said something wrong before where I said we don't necessarily need this to be a rhombus, but I think we do. So let me just point out that this angle here and this angle here are alternate interior angles, which means that they're equal. And since they're each equal to the ones next to them, these are all 4 angles are equal. And so we do have a rhombus. These are obviously parallel because they're from this rectangular strip of paper, and then these ones are also parallel because they have the same angles going up here and here. All right, great. So we've got a rhombus here, and we can draw the diagonals of the rhombus, which is going to help us compute the area in a different way. So we've got the long diagonal going up like this, and we've got the short diagonal that we already had here. And I didn't draw this very accurately because in a rhombus, these 2 diagonals are actually perpendicular. So we can draw that perpendicular even though they don't look perpendicular. But what that means is that there's a rectangle which is double the area of the rhombus that's at an angle over like this. And it's got, basically you can imagine folding in the corners. This triangle would be the same as this one in here. And so that if we multiply the 2 diagonals of the rhombus, we'll get the area of this rectangle, which is twice the area of the rhombus. I'm going to erase that rectangle and get back to just the rhombus. But I just wanted to make that argument about multiplying these 2 diagonals. One of the diagonals is x, which is what we're looking for. So the area of this rhombus, which we know is 72, that's going to be half the area of the rectangle. So the rectangle is the width times, the width times the length of this rectangle is going to be equal to twice the area of the rhombus, which is 72. So 2 times 72, which is 144. Okay, so if we have the width and the length, well, let me replace the width by x, because the width of this thing, if we call this the width, is x. So x, and instead of calling this the length, I'm going to call this the other diagonal maybe. So let me fix that as well. We're multiplying these 2 diagonals. One of them is x. It's the width of the rectangle, or the length of the rectangle. But then this is the long diagonal. We'll just call that d. So x times d is equal to 44. Alright, so now we can use the Pythagorean theorem. Let's grab another color. We'll show this triangle along the bottom. There's a line along the bottom here, and we can form a triangle going up like this, a right triangle, and that's a right angle, and we can use that to compute this long diagonal. Basically what we have here is we have a length of 12 from here all the way over to here. And then what is this length? Well, this one is 12 going up here, and this one is 6 here. So we can compute this as the square root of 144 minus 36. And so now we know this distance and we know this distance, so we can compute this one. Let's get out our calculator here. So let's see. Okay, I'm going to put it up here. And what do we have? So we have that diagonal is going to be, well, let me just write we've got 12 plus the square root of 144 minus, oh, did I say minus? Yeah, 144 minus 36. That's going to be one side. That's going to be that long yellow side along the bottom. That thing needs to be squared, right? We need to square that thing. And then we need to add that with 6 squared, which is 36. And then we need to take the square root of that whole thing. So that should give us that diagonal. Oops, I forgot to import NumPy. So that should be, that 23.18, that should be this long diagonal. That's D. D is equal to 23 point, whatever it was, 23.18. So we can take 144 divided by that. That should give us X. 144 divided by, well, I'll just do it all again. We'll do it like this. 144 divided by that thing. And that gives us 6.21. They wanted it to the nearest hundredth. So 6.21 is going to be our answer. That is what we were looking for, is this distance here, this X. So it's 6, well, that's not a very good color. Let's grab this one. We're going to say it's 6.21. 6.21. All right, great. Let's move on to the next one. This is problem number 7. This was kind of an interesting problem. It says that Matthew draws points A, B, C, D, and E on a paper. Okay, so we got A. We don't know where they are. B, C, maybe D's over here. E might be here. I don't know. We don't know yet. Well, we've got these 5 points, and the lengths of segments AB, BC, and CD. So that's this length, and this length. Those 4 lengths are 4, 3, and 7. Not necessarily in that order. Okay, so we don't know which one's which, but we just know that those are the 3 lengths. And then it gives us the lengths of segments DE, so DE, AD, and AE, these 3 lengths. Those 3 lengths are 14, 23, and 19. And then it asks us, what is the length of segment AD? Okay, we know it's got to be one of these 3, so if you have no idea, you can just guess one of those 3. You'll have a 1 in 3 chance of getting it correct. That's nice, but we don't know which one it is, right? At least not yet. So the thing is, they didn't really give us very much information. And you might think, oh, well, there's not very many constraints here. I mean, we have a triangle here. It could be, you know, the 14 could be here or here or here. But we do know that the sum of these 3 distances is the sum of these numbers, which is 14. So that means the distance from A to D can at most be 14. It can't be any longer, because if you stretch A, B, and C in a straight line and with D, A, B, C, D like this, just stretch them out as much as you can, the farthest apart you can get A and D is 14. 14. And you can't get them any farther apart. And we know that A and D have to be no less than 14 apart, because we know that AD is one of these three numbers. And so it can't be this one, it can't be this one, because it just wouldn't reach. These other four segments wouldn't reach. So it has to be 14, which means A, B, C, and D are all on a line. But anyway, the answer there is just 14 centimeters. So a little bit tricky, but not too bad. All right, let's move on to the last problem from the target round. This one says there are 4 baking teams that compete in a tournament consisting of 2 semifinal rounds and a final round, as shown. So they each have a seed. It says both the semifinal and the final round are a series of best-of-5 matches. Once a team has won enough matches to clinch a series victory, no more matches are played in that series, and no match ever ends in a tie. If the higher-ranked team has a 2/3 chance of winning any particular match, what is the percentage probability that the Connorstown Confectioners, that's rank 3 here, will win the tournament? Express your answer to the nearest 100th of a percent. Okay, so what has to happen for the Connorstown Confectioners to win the tournament? First of all, they have to beat Belleville in the semifinal round. And it's a best-of-5 tournament. So there are 3 ways that they could win that semifinal tournament. They could either win with 3 straight wins. So maybe I'll just write it as the win in 3 rounds. Win in 3 rounds. Or they could win in 4 rounds, or they could win in 5 rounds. Now what's the probability that, if we can compute these 3 probabilities, we can just add them all up. That would be the probability that they win. What's the probability that they'll win in 3 rounds? Well, they'll have to win the first game, which is a 1/3 of a chance, since they are the... Oh, let's see. Oh yeah, because they're paired up against number 2. So it's a 1/3 of a chance because they are the lower ranked team. The higher ranked team has a 2/3 chance of winning. That means the lower ranked team has a 1/3 chance. So they'll have to win the first one. They'll have to win the second one, which is also a 1/3 chance. And they'll have to win the third one, which is a 1/3 chance. So we can just multiply those together to get that probability. If they win in 4 rounds, there are going to be 4 games. 3 of them are going to have to be wins. So 3 of them are going to have to be a 1/3 probability, a 1/3 probability, and a 1/3 probability. But the other one, they're going to lose, which is a 2/3 probability. So we can multiply these all together. That will give us a probability that it's in one particular order. But actually, this order is not possible, because if they won the first 3, then they just win in 3 rounds. So the 2/3 has to go either first, second, or third. So there are 3 possible orderings of these numbers. It can't go at the end. So since there are 3 possible orderings and they all have the same probability, which is a product of these 4 numbers, we can just multiply this by 3. And then let's go over here. So we're going to talk about winning in 5 rounds. To win in 5 rounds, there will be 3 games that they win. So again, it's a 1/3 times a 1/3 times a 1/3. But now we have 2 where they lose. So we have 2/3 and 2/3. And basically the win has to come at the end. So the other one of these wins has to be at the end. So if we don't worry about order for that one, we have 2 where they win and 2 where they lose in the first 4 games, and those can be in any order. And so how many ways can you order? It's basically 4 choose 2, which is 6. So we have to multiply this by 6. So that's going to give us a probability that they're going to win the semifinals if we take this product plus this product plus this product. And we can pull a 1/27th out of each of those. So we have 1/27th times 1, that's this part, plus, let's see, here we have 2/3 times 3, which is 2, plus, and here we have 4/9 times 6. So I can cancel this 6 and make it into a 2 here. So we have 8/3. So 8/3. And if we compute this whole thing, what do we end up with? We have, let's see, 3 is 9/3 plus 8/3 is 17/3. So this is going to be 17/80, let's see, yeah, 81. 17 over 81. So what do we know from that? We know that there is a 17 over 81 probability that the lower ranked team is going to win when two teams meet together. All right, let's clear a little bit of space. I think that's going to be a really important thing for us to know. We're almost there just from that, even though we've got to consider all three of these games. But using that number will be very, very useful. So let's see what happens next. So in order for Connorstown to become the champion, first of all, they have to win their semifinal game. So that's going to be a 17 out of 81 chance. And then what has to happen? Well, we could either have Appleton or Durham win in this semifinal game. So let's consider the case first where Appleton wins. So first of all, how likely is that? Well, they're the higher ranked team. So that means they're going to have 1 minus this probability, right? So what's 1 minus that? It's 64. 64 out of 81 is their probability of winning. So we're going to multiply by 64 out of 81. That's going to be the case where Appleton wins. And then when Appleton and Connorstown meet, Connorstown will be the lower ranked team, so they'll have a 17 out of 81 chance of winning. So this is the probability that all of that stuff happens. But that's not the only thing that can happen in order to have Connorstown be the champion. The other thing that could happen is that Appleton could lose, right? And Durham could win. And if that happens, well, we're still going to have Connorstown win here, which is going to be a 17 out of 81 chance. And then there's another 17 out of 81 chance that Durham beats Appleton, even though they're way lower ranked than Appleton. I guess still ends up being the same because we just have this rule here. And then we're going to have the match between Durham and Connorstown. And here, Connorstown is going to have the advantage. They're going to be higher ranked than Durham. So they're going to have a 64 over 81 chance of winning. So these are actually the same thing. So we can just say 2 times this thing, right? 2 times this thing. So we can just grab ourselves a calculator, pull that in, and we can just compute this, right? So we have 17 times 64 times 2. That's on the numerator. And then we're going to divide by, in the denominator, we have 81 cubed, right? So 81 cubed. And that's going to give us 0.0696. And how do they want the answer? They want the answer to the nearest hundredth of a percent. So this, to make this a percent, you would multiply by 100, right? So that's a 6.96% chance. Okay, so let's grab yellow and we'll write 6. Oops. We'll write 6.96%. That's our final answer there. Okay, I hope you guys enjoyed this video, and I'm going to be also making another video, so stay tuned. I'm going to make a video about the team round as well. So have a great day, everyone. Bye.